Okay, let's talk about section 7.5, angles of elevation and angles of depression, page 371 in your book. Well, what is an angle of elevation and an angle of depression? Let's first look at the left-hand picture here. Angle of elevation. Suppose we have a house, we're looking out the house at the cliff, and we want to know how tall the top of the cliff is. Or the angle of elevation is our line of sight looking upwards. So the degree of this part of the right triangle that's formed by the dotted lines is called the angle of elevation. So that's the angle at which you're looking up towards something. If you want to go the angle of depression, let's look at this example. I've got a lighthouse on top of the cliff looking down at a buoy, and my dotted line forms a triangle, and you see that the angle of depression is how far your line of sight is looking downward. So angle of elevation is looking upward, the angle of the imaginary right triangle. Angle of depression is the angle looking downward. So let's say we have this problem right here. Okay, in this problem we got at point A we have an airplane that wants to take off. And at point B is the top of a mountain that the airplane has to fly over. That mountain is 400 meters tall. We have area before we get to the mountain of 2,025 meters. But we don't want to fly just over the mountain. We want to give ourselves a 50-meter leeway. So we are going to miss the mountain by 50 meters. So we want to find out what is the angle of elevation for the airplane to get to 50 meters over the mountain. So from angle A, what do we know? Well, we know that the opposite of angle A is this 400 mountain plus the 50 we want to miss the mountain by, so 450. We know the adjacent in this triangle formed by the mountain and the airplane is 25 meters. We think, well, what about the hypotenuse? Well, the hypotenuse is not given to us. We don't know what the hypotenuse is, but guess what? We're not asked to know what it is. We're asked to find out what that angle of elevation is. So we don't even need to know the hypotenuse. And finally, we're asked to find out the measure of angle A, which is what we're talking about right there. So when I look at this problem, I see that I have an opposite and an adjacent. What is the function that I use when I know opposite and adjacent? Well, that is tangent. The tangent of x is the opposite over the adjacent. Well, if I plug that in, the opposite is 450, the adjacent is 2025, and I calculate that to be 0.2 repeating. So now we're looking at tangent of x is equal to 0.22. I then do the reverse of the tangent function, which is the inverse tangent, or the arctangent. X is equal to the inverse tangent of the 0.22, repeating 2. And when I plug that into my calculator, I get x being approximately 12.5. Okay, and 12.5, well, x in this situation is the degrees of angle A, so 12.5 degrees is approximately what the airplane has to fly, angle of elevation that the airplane has to fly to miss the mountain by 50 meters. All right, now let's look at another example. Let's look at a truck example. Here's my drawing now. This is the back half of the truck. There's the wheel for the truck. And this has a ramp coming out the back of the truck so I can load the truck up. What I know about this truck and a ramp is that it is 3.5 meters off the ground, or 3.5 feet off the ground, and that the angle of depression is 10 degrees. So, what do I know? I am going to from angle B, right down here, what do I know? I know the opposite side of angle B is 3.5 feet. I know that the measure of angle B is 10 degrees. How do I know that? Well, I've drawn imaginary parallel lines to make this two lines here up top and bottom, and since these are parallel, this becomes a transversal, and this angle being 10%, the angle of depression here is 10%, so the angle here of angle B is also 10% because it's alternating interior angles. Okay, so we know that the measure of angle B is 10%, or 10 degrees, not percent. Okay, and then this time we're asked, what is the length of the hypotenuse, or AB? So, what is the length of AB, which is our ramp length? Well, what do I use? What tool do I use, or what function do I use when I know the opposite and I'm looking for a hypotenuse? Well, I can use sine. Opposite and hypotenuse are part of the sine, right? So, since I know the degrees of the sine, I say the sine of 10 degrees is equal to the opposite, 3.5, over my hypotenuse, which is AB, which is what I'm looking for. So then I multiply both sides of this equation by AB, cancels the AB out on this side, and I'm just left with 3.5, and I take the sine of 10 degrees times AB on this side. Now, I divide by the sine of 10 degrees. AB is equal to 3.5 divided by the sine of 10 degrees. So now, once I plug that into my calculator, that tells me the actual answer. And I just went and did the sine of 10 degrees on my calculator. It's 0.1736 and so on. So 3.5 divided by that gives me approximately 20.2 feet. So the ramp up above comes to be approximately 20.2 feet. And I used the sine function to figure that out. All right, now let's take a look at one last thing. Let's look at an example this time of boats on the water. Okay, well, let's take a look at the picture first before we take a look at some of the drawings or some of the formulas. Let's take a look at this picture. The first thing we notice is that we've got that lighthouse again on top of my cliff. The cliff is 110 feet tall and the lighthouse is 85 feet tall. So my dotted line on this side of my right triangle is going to be 195. Everybody see that? The other thing I know is that along the water line here, I have two boats. One boat at point A, one boat at point B, and then I know that the line of sight, line of depression, or angle of depression for looking from point C, the lighthouse, down to boat B is 33 degrees. The angle of depression from the same lighthouse down to point A, or boat A, is 57 degrees. Okay? And they're asking us, use this information to figure out how far apart boat A and boat B are. Well, the first thing I do is look, how am I going to figure out how far apart they are? Well, using these letters to designate the parts of the triangle, we see that DB, which is the full length of boat B from the cliff, minus DA, which is the length of the boat A from the cliff, will tell me how far apart A and B are, boats A and B are. So I've got to figure out DB and DA. Luckily, I can do that from the information they've given me. So what do we know? Well, let's take a look. We know that angle B, this angle right here, is 33 degrees. How do we know that? Once again, I have parallel lines with these dotted lines that I drew. And since this angle is 33, this bottom angle from boat B is 33 also. Okay, so we know that the angle B, when we're looking at angle B, that we know that the measure of angle B is 33 degrees. We know that the opposite from angle B is 195, the cliff plus the height of the of the lighthouse. And do we know the adjacent? Well, the adjacent is DB. Well, that, if you remember, is exactly what we're looking for right up here. So we want to solve for DB. So what function do I use when I know the angle and I know opposite and adjacent? Opposite and adjacent tell me tangent right away. So I'm going to use the tangent function. So here's my tangent function. Tangent of a 33-degree angle is equal to 195, which is the opposite that we figured out up here, divided by the adjacent, which is what we're trying to figure out, dB. So we look at that a little closer, and we see that I multiply both sides by dB, dB, and dB, so I'm left with dB times tangent of 33 degrees is equal to 195. Now I'm going to divide by tangent of 33, and I know that now dB is equal to 195 divided by the tangent of 33. And if you do that calculation on your calculator, dB turns out to be approximately 300.27, and remember this is in feet, so I could write feet here. Okay, well now we know that. What else do we know? Well, when we need to know the answer to dA now. We've got dB at 300 feet. Now we need to find dA. Well, we know the angle A. From angle A, what do we know? We know the measure of angle A is 57 degrees. Once again, we know that because of alternating interior angles. So this guy to here is 57 degrees. Okay? I'll move this up a little bit. We know the opposite. Well, guess what? It's the same opposite as before. Instead of coming from B, now we're coming from A. The opposite is still that 195 cliff, 110-foot cliff plus 85 of lighthouse for 195. And the adjacent now is AD, or DA, and that's what we're looking for. Once again, going back up to our original equation of how to solve this problem, dB minus dA is going to be the distance between the two boats. We know dB, now we're going to calculate dA using the same method we did before. So doing that method, first thing we do is we say the tangent of 57 degrees is equal to 195, our opposite, over our adjacent. To multiply both sides times dA, and I get dA equals times the tangent of 57 is equal to 195. Then I divide by the tangent of 57, and once I divide by the tangent of 57, I get the following answer, that dA is approximately 126.63 feet. Again, I can write feet here. Okay? Well, now I know go back to the top of our equation, how we said we were going to solve this. I know dB, I know dA, so now I can calculate how far apart the boats are, and that's done right here. dB was 300.27 minus 126.63, and the boats are approximately 173.64 feet apart.